Question number 12 is a chi-squared goodness of fit test. So here the null hypothesis value is that the percentages are as advertised, 50%, 25%, and 25% for peanuts, almonds, and cashews respectively. So we need to put the actual counts that we've observed, the 215, the 91, and the 75, into list 1. So we'll go ahead and do that, although we need to know the total sample size. So the 215 plus the 91 plus the 75, that will tell us how many observations we have in total. There are 381. So I'm going to clear out what I have in list 1 and in list 2. So in list 1, I will put the observed counts. That's the 215. And that is the 91 and the 75. So the expected counts then are found in list 2, that's where we should put them, but the expected counts are the 381 times the percentages in the null hypothesis. So 381 times 0.5, that gives us 190.5 peanuts, and you should leave it as 190.5. Don't round up to 191, and you should document these expected counts on your paper and on the AP exam. So the next two expected counts should be the same, 381 times 0.25 each. So that's 95.25, and the third one will be 95.25 also. So at this point, we can use the chi-squared goodness of fit command. So this happens to actually be a goodness of fit test, whether it's a goodness of fit test or a test for homogeneity or a test for independence or association. You can use the same command. What's important is that your observed counts are in list 1, the expected counts are in list 2. And again, the degrees of freedom here are 2, but this is not number of rows minus 1 times the number of columns minus 1. This is a goodness of fit test, so there are 3 categories, and it's 1 less than that number of categories, 3 minus 1 being 2. So this test also has 2 degrees of freedom. So this confirms the chi-squared statistic. There's the 7.646, and there's the p-value of 0.0219. Again, just like with the t-test, you would want to write down your statistic, which is a chi-squared statistic. You'd want to write down your p-value. And just like on a test for 1 mean, for 2 means, for a t-interval for 1 population mean, or a difference between population means, you want to write down your degrees of freedom. Here, that's 2 degrees of freedom.